I think 2020 to 2024, in that 4 years, you will see a lot of machines at different places. So,
I think Japan will be first in 2020. I think Europe will probably be in 2022, and whether or not U.S. is before 2022 has everything to do with initiative. U.S. could certainly be there before that, and probably will, but there's no funding or commitment at this point.
Someone here said China, right?
Yeah, I would think China seems to surprise.
Yeah, but then the question, if that's the system is going to be built just to be impact on the top 500 and say it's exascale, or a system that actually going to be usable.
It's hard to get information on China, and China would be the most popular vote if you polled everybody. I personally am dubious because we haven't seen yet what the commitment to supercomputing will be from the new Politburo, from the new cabinet. They go on 10-year governments essentially, or they're ostensibly 5-year governments, but they're always automatically re-upped for another 5. And 2 years ago, they moved to the new regime under Xi and Li. Now, Tianhe 2 was out of funding from the previous Chinese administration. The interesting thing is that the Chinese Politburos are typically dominated by people with science and engineering backgrounds. And that's not the case with the new administration. The new cabinet is largely dominated by economists, including Li himself, the premier. And their primary objective is the development of a viable Chinese middle class, not so much with chasing the new engineering or scientific breakthroughs. The last thing I'll say about it is that they don't exactly have 100% free press in China. And we've actually seen over the last years articles coming out of the Chinese press that are openly critical of the Tianhe 2 system and how it was a waste of government resources. Well, how does that press get out there unless maybe the government's thinking about backpedaling on this and changing direction? So I'm trying to connect the dots on this. All I'm saying is I'm dubious about what the level of commitment is in China to exascale over the next 10 years. Not like I didn't think of China as an option. Well, I mean, you could, or it could just be that one administration doesn't think the same as the previous administration. We have that in this country too. I'll let these guys go first. Yeah. Power consumption for exascale.
Yeah, actually, if you look, for example, at Coral, if you look, for example, at what's been said publicly about Coral, the power, the compute power there is anywhere, 3 to 4 times higher or something like that. The energy consumption there is only about 10 megawatts. So we are seeing some improvement in efficiencies and the like. So how do you project that out? If there are no improvements, then maybe you're talking about 50 or so, but I'm sure there will be improvements.
DK, you were talking about power earlier.
Yeah, I mean, in my talk today morning, I indicated, the power is a big concern, and it has to be handled at all layers. Starting from the hardware to the software, to the runtime, to the applications. And as we saw in the passive talk and what Rich is telling, the Coral systems are like one first generation you can see, which is trying to bring that under control. But of course, that is not the exascale. We still have another tenfold performance gains we need to do. But at least this will try to show us some initial solutions which are not power hungry. And then we can try to extrapolate from there and then go to the next revision, which will be much more match with the target, the exascale target.
I think the Americans' viewpoint on restricting the power consumption is part of what's going to slow down the U.S. exascale initiative relative to the other ones. I think Japan and China are a lot more willing to stand up a machine that's 100 megawatts if it'll be the first to an exascale. And if you bring Europe into the equation and presume that it's CEA who would be first in Europe, there's again a lot of potential energy there. So, you know, if you have a willingness to relax the energy requirements and say, sure, we'll put one up at 50 to 100 megawatts, you can deliver it sooner. The U.S. is less willing to do that. Yeah, that's not an official statement from any government, right? I'm just guessing here. It's my job. Any hope of technology getting beyond 3 gigahertz? Not for volume markets. There will be specialty markets like the high-end gaming market where overclocking is already a thing. Anywhere where you see a real need for ultra high performance. You could argue for high frequency trading, except that's more latency focused than it is compute focused. So other than the high-end gaming market, I can't name any right now. That doesn't mean there aren't any, but anything that's substantially higher than 3 gigahertz would remain a niche market, and most of the volume will stay out of it.
Yeah, you can also ask, by the way, if it's the frequency or the number of cores, right? When you buy a CPU today, you can get higher frequency, but then it's going to be less number of cores you can use. Or if you want more cores, it's lower frequency. So now it's become a question of more the application probably. That might be something that DK can talk to, but if application is going to be moved to be used more cores, then I think it's kind of a better because the frequency will not scale.
Yeah, I mean, it is a question of like both the product of the number of cores and then the rate at which they're operating. So if you can really parallelize across a lot of cores who are running slower, you may get much more benefit than with fewer cores and with faster clock. Mm-hmm.
I think there are things on the horizon, but I think you're a lot more likely to see something like 3D chips in terms of the continuation of Moore's law. You know, it's a funny argument whether or not that constitutes the end of Moore's law. If you really call Moore's law, you know, transistors per square area, and I start stacking them, well, now I'm still doubling per area, aren't I? I'm just going upwards. It's right. So that's going to be, I think, the new cheat to get past Moore's law. There's the blue shirt there. You were next.
Sure. So there's commodity processors, but for like the top 10 HPC, I don't see commodity interconnects the same way. There's a lot more specialization. Do you see that as a continuing trend, or that
Well, I think some of those specializations are going into the commodity stacks and the like. I think the fact that these are useful, you see multiple vendors trying to do the same thing, you know, trying to offload more things to the network and the like. So whether you know they remain with proprietary solutions or not, I mean, I think the fact will be that there will be more processing of data migrating to the network. You know, so I think that's a trend that's not going to slow down.
yes, as to what architecture
I won't touch that. I won't touch that.
I just want to add a point there. I mean, if you see the current top 10 or top 20 for the last several years, of course, the IBM Blue Gene has been holding on to a lot of places, but as we know that line is discontinued. So in the next few years, you may see some different trend there. They
You mean
will
the blue jeans?
yes, the blue
discontinued.
jeans
Yeah.
being discontinued, those will get phased out and newer technologies will be coming out. So that landscape will change in the next few years.
But then you have the power that coming, open power that comes from IBM, right? So the blue gene is power. Now you have open power that comes in,
Yes.
and in 2017, at least 2 of the systems out of 500 is supposed to be with power.
So I was referring to the blue gene interconnect purely from his
right.
perspective.
So I'm kind of jumping on this one from the CPU perspective, and I think you mentioned that Addison as well, right? There is x86, which is probably the dominant solution right now. You see open power. There is ARM getting into 64 bits. You mentioned the Cavium announcement that supercomputing of 48 cores, supposed to be like a Xeon-like performance, more or less. FPGAs also maybe something that will become of an interest of something like as a co-processor in a system, and of course the GPUs, right?
Right.
So are we going to see more of various architectures instead of a dominant x86?
Well, that was the big theme of my presentation, is you were returning back to specialization. I think the tough thing in your question is what's even meant by the term commodity processor going forward. Do you mean an Intel x86 processor? I actually mean this non-rhetorically. What do you mean by commodity processor?
Yeah, I guess that's a good point. I'm thinking, you sort of different stages. There were more like gate arrays.
Right.
Systems built out of components or programmable but then you're scaling. There were fewer players.
Right.
More higher volumes. So Intel, just the standard Intel architecture.
Right.
Even power, Spark, all those. There were more instruction ISAs earlier on. Now much fewer choices.
Intel, well, yeah, almost equates to the x86 market. Now, the funny thing is that both IBM and Intel would start getting irate that you're referring to Intel x86 as commodity, right? IBM would get irate about it. You hear Dave Turek go off on this. That guy rants more than I do. And, he'll say, why do you call Intel a commodity processor? It's entirely proprietary to Intel, right? What makes that commodity and it makes anyone else a proprietary processor? Whereas Intel will get mad from the other end of the spectrum, where they don't want to be thought of as something that anyone can just make. And in fact, Intel has been moving up the value chain through integrating or acquiring and presumably integrating interconnect technologies, which you talked about, also storage technologies, going forward. I think you get through another iteration of isn't it from Intel here? Right? Okay, so you tell me if I get in trouble, all right? But you get through another iteration of tick-tock, and some of those technologies start getting integrated on chip, presumably, which has nothing to do with any kind of NDA presentation from Intel. But they go and they acquire Fulcrum, they acquire the InfiniBand business from QLogic, they acquire the interconnect futures from Cray. Why? Right? Are they going to integrate any of that on chip? If so, what does that mean in terms of now is the interconnect commodity, or are you locked into an Intel downstream interconnect somehow? And all of that plays into this Intel versus non-Intel dynamic that's going on in the proverbial sandbox that I drew out there.
Yeah, I was thinking really so much in terms of the IP as opposed to volume.
Right. Volume, it's going to be x86 versus ARM, right? When you're on top of the mountain, when you've got the whole market like Intel has almost, then the big threat is the paradigm shift, right? And it's all of the ARM devices in our pockets and our tablets. And if that eats away the x86 market from below, then what's the role of it? Does that affect the role of x86 in the high-end market where ARM might not have reached on its own? I'm sure the Atom processor will go take over everything, right? Then we'll be able to get out of this argument.
Yeah, one comment, and then I'll let you ask. One comment, Addison, you talked about integration. So one question to think about is that an integrated device, or that's more of a packaging perspective, in the sense that are you taking separate silicon devices and putting in one package, which is packaging, or are you putting everything on one silicon, which I'm not sure that.
Well, see, that's the question I would advise Mellanox to ask people who are, evaluating their InfiniBand solutions. I think what gets integrated in a sense is the NIC or the HBA, depending on exactly what architecture you're talking about, gets moved on chip. And then to the extent that it's integrated versus not integrated is a question of software or perhaps middleware.
So the question, when you talk about integrated, the question, the first thing you need to think about if that's an integrated device or not, or a packaged device.
Good point.
Integrated means that everything is on the same silicon. As far as what published outside, it's not the same silicon, because Intel is going to sell a lot of CPUs that will not have any OmniPath on it, for example, for other markets. And therefore, it's more packaging of different silicon devices in one package. So it's not a real silicon integration. If you ask me, in my view, the goal is, integration is not the goal. All right, the goal is to reduce TCO. Now, for reducing TCO, you can do multiple things. You can say that doing an integration might be something like that. But Intel, for example, and that's actually an integration. That's much better. Thanks, Mike. Integrated graphics into the CPU.
Yep.
But you have some here from NVIDIA that's going to tell you that they're still selling GPU.
Yep.
So it's all about cost performance, or it's all about reducing TCO. It's not the integration. It's not the thing. The thing is how you get a better cost performance.
I didn't mean to predict a winner in any sense. I just meant to point out the industry dynamic that the competition is shifting. No, I totally get your value proposition.
Right. The reason I'm saying that is because I don't think it's, in my perspective, I don't think it's Intel against the world or the world against Intel from that perspective. I mean, you're going to still seeing a lot of systems being sold with x86 on top of it, or the CPU, and then NVIDIA GPUs or RD interconnect, and that does not mean that it's all Intel or not all Intel from that perspective. I think users will have a huge choice to decide what's going to be on the platform. But that's kind of from a comment on the Intel versus non-Intel. You have a question or comment?
The question was, what market segments do we think the Xeon Phi will be most successful in? That is a question I have put to Intel, because I want to know from Intel, where are you going to target this? You remember that Intel, in a rare misstep, really had trouble with the product launch around Titanium. And I think what they were reluctant to do that they should have done is put out a white paper that says what applications you want native 64-bit for and what applications don't you. And their lack of willingness to make that statement really hurt them in the market and gave AMD the opportunity to drive in the middle with Opteron. And they're in danger of making the same mistake again with Xeon Phi. They need to make a very clear statement about what application areas they're targeting with Intel Xeon Phi. Don't be afraid of cannibalizing your own sales. You're coming out with the product. Presumably, you think there's a market need for it in certain application areas. Tell us what those are. Tell your own field guys where they're selling one versus the other. We really have not seen good guidance even from Intel on that. Anyone else want to touch that one? No?
You have no information.
Well, actually, I'm in danger because I have information. I have to be very careful not to violate anyone's NDAs when I give an answer on that. Yes. Yeah. Right. So summarizing, what can happen among the hardware vendors to improve the hardware-software collaboration to solve the software scalability problem? That's these guys.
I think that is very important. I indicated like a lot of these co-design opportunities are coming up, at least from the Exascale angles. Some of the vendors and researchers are actually working together to come up with the next generation hardware and software together. In a commodity space also things are happening, but not in a very tightly integrated manner. But over a period of time, I mean, just like for myself, I mean, I work with Mellanox folks, NVIDIA folks. We know like what technology is coming, and we have some joint projects together so that we bring like our MPI stack to be ready for those features soon. So we have been able to do that for the last several years. So that's how you see when the products are announced, our stack is ready and people can use it. But more such integrations are needed, or very integrated dialogues are needed between vendors, both hardware and software.
And I'd add to that too that as part of development that I'm aware of in the context of hardware, whether it's internal or whether it's between companies, one of the things that frequently happens is this trying to understand what software really needs and what software doesn't need. What hardware can do better, and try and put something together that overall gives a better solution. So standard.
Really, any hardware vendor is motivated to have stuff run better on their platform than on other platforms. And there are a lot of hardware vendors that I talk to who will maintain they spend more engineering effort on software than they do on hardware. We've seen this before with other changes between ages in computing, like when we went to MPI. There's a quote, I think Mark Twain, history doesn't actually repeat itself, but it does rhyme, right? And I think that's what you see. I look at what NVIDIA has done with CUDA is a great example. Without that software initiative, they can't get the GPU traction that they've had. Ask Mellanox how much time they spend on software versus hardware, and I think you'll find that a lot of the intelligence in those chips is in that middleware software stack of how you manage these things. So I think any hardware vendor has a vested interest in the software surrounding their own components. There's a meta question above that of how do you get all those to play together, right? Consortia like Open Power become a big deal, because now if you get a consortium of IBM and Mellanox and NVIDIA and presumably other people all working on a software stack for a consolidated solution, that can really step up another level. Intel, of course, will try to put everything into Intel tools. That's what, and so they should. They'll put it out there and say, if it's Intel tools, it's standard. That sounds nice, right? It's certainly proprietary to Intel, but to the earlier question, people think of Intel as commodity. So, there are a couple of different ways it'll go. I don't think anyone's out there going to do a whole lot of work just to benefit the world or benefit other companies, but not me. The hardware companies are in it to sell their own stuff. No, was that not your question? Okay. Do you disagree with me? You're frowning at me.
You want him to be sorry to ask the question, or?
Yeah. Mm-hmm. Right. To the extent that exascale is different, we need to rethink the link between hardware and software, or else what's the point of what we're doing at exascale? That actually gets to the question Gilad didn't ask around what does exascale mean anyway, right? If you just stand up an exaflop and no one's able to use it, have we really reached exascale at all? I was asking that question myself, Gilad, a lot, as you know, at different conferences. Chris Willard, my partner, I think had a nice succinct answer that winds up being my favorite one. He said that, I'm asking about what's the difference between exascale and exaflop, right? Why did we change the noun after the prefix? What does that word actually mean? And if it's going to mean anything different than exaflop, maybe what it means, what he said it means, is it's an exaflop plus the software, right? And if you have something running on it that's using an exaflop, we can call it exascale. But if it's an exaflop and nothing's running, then it doesn't count. And I'm happy to accept that answer. I don't know if it's a popular one. Probably the moment anyone puts up an exaflop of anything, someone will say the exascale era has arrived. But if it's going to mean something different than exaflop, that's probably what it is.
So are you referring to this more from a perspective of programming environments and stuff like that? From that?
No, I love commercial now. Software, hardware. Do they have a connection right now? That's what it's kind of traditional. It's the same kind of collaboration happening throughout our 60 years. Maybe exascale also means a different connection between hardware and software in the way that companies communicate. I can see that fitting into the exascale one. And then what Gilad said that it's not about the Intel versus the world. The exascale is exactly what Gilad said that it's a new, ecosystem of things that are different and all of them will coexist. I cannot really follow the question.
Have you thought about a career as an analyst? Do you like writing white papers?
Work with you, huh?
Do you believe
I think on the panel, they're not including insulting the audience,
do you believe that the first exascale will be homogeneous or heterogeneous?
Do you mean in terms of different processing elements? So the question was, will the first exascale system be homogeneous or heterogeneous? Given that I think it will come in Japan, I think it will be heterogeneous. But I don't think, there's only one answer to that. You're asking about the first one specifically. Roll the dice and what the first one is.
I think it's one of the other question, right? Which is, so today, Lintac HPL is either it's based on CPU or CPU or whatnot. Does exascale or exaflop also consider FPGAs and other accelerators into the equation? You have a smaller, more dense machine.
No, not if it. Yeah.
Depends to the question of software.
Oh, but that's why.
All of these boards and all of these unlike that means content one unit across the software.
Yeah, that's why I was trying to drive back and understand what the question really was. Because if it really is more than just a small number of apps using it, we're going to be using the same programming environment we are today. I mean, they're just the reality of time, reality of amount of software and the like. There may be, there are efforts, as DK alluded to, that are trying to change that, but they're very small, overall.
Yeah, and I think going back to your exascale saying totally new things are happening, it is not true. I mean, now you see we are in 2015 and we are talking about 2020. I mean, so I see like exascale is a target which is driving people to think newer stuff. But a lot of ideas are also getting percolated to the current generation or next generation systems. So I think we'll see it as like a continuum. I don't think it will be totally saying these are traditional machines and these are exascale machines. The more in another 3-4 years, so we'll have some observation of how these machines will look like. And getting back to homogeneous, heterogeneous, I think it will be heterogeneous. I mean, that's what we see at least currently the trend, even in the top 20-30 systems, you will see these are all accelerators, either NVIDIA or Intel mic. I think that technology will continue to grow. FPGA may again come inside, but I have not seen at least a very large scale system with FPGA together with CPU at this time. So if you just use the current generation data and try to extrapolate how it will look in another 7-8 years, I think it will be some heterogeneous machines.
For me, I separate out exascale, where exa is a more or less arbitrary mile marker on the highway that we will go past and then we'll start looking forward to the next one, right? I separate that in my head from the architectural shift that's going on in the industry, this new era of computing. And in terms of history rhyming, this isn't really the same as petascale, but it's pretty similar to where we were with Terra. Now, we didn't talk about terascale then, we talked about teraflops, but that's the other time when we had a milestone we were chasing at the same time as a new architecture in play. Because the first terascale systems were clusters, which were not well adopted anywhere else in the industry, and they faced the same criticism about they can't be used efficiently, we don't have applications that run on them, they're really hard to program, who's ever going to adopt these things outside of general scientific research, right? Eventually the ecosystem comes around. More people buy them, you start figuring out how to program them. The market will catch up to the new architecture. Whether or not it catches up to the new architecture in time for the arbitrary milestone that's exascale, I think is highly in doubt, right? But that's where we were with Terra also, and the market eventually sorted itself out. Once exascale becomes common enough that national labs have them, what kind of applications does that enable? That's one of my favorite topics, but you guys go first.
I mean, I think that the question, if you go back 10 years, the same question was there. I mean, if the petaflop systems will come, what will be the applications? I think broadly, if you see, I mean, existing applications have continued to grow in terms of like different granularity or dimensions or finer time steps. So those regular applications are continuously growing. In addition to that, now you see some new generation of applications, like let's say a lot of these graph-based applications, they didn't exist like, let's say 10 years back. So those are the kind of new things which are coming. So I think similar kind of things will happen. So whatever the current generation applications where people have understood these things, they will be able to really go for the newer capabilities and to have more advancements in the science. But in addition to that, might be a new generation of applications will come, which we don't know yet.
I think I'd agree with that. I mean, if you look at GPUs, people have been trying, an HPC for at least 5 years, to really try and figure out how to do things. 10 years from now, I think there'll be a lot larger body of knowledge. People will know how to use them better. I mean, so.
My favorite one, there are many. You pick an industry and you could start saying what could come next. My favorite one that's, I think, on the reasonable time frame that you're talking about within the next 10 years is all in brain research. You talk about something that you have to simulate rather than physically test. It's hard to get people to sign up for physical brain tests in exchange for a $50 gas card or whatever they're going to get, right? I think in the next 10 years, we're going to map the human brain. There's going to be a definitive mapping of the human brain. And you think of what that entails, what that means, and then relate it, going back to my rhyming thing, with mapping the human genome. Mapping the human genome didn't end a question in as much as it started a whole new field of research, right? And if you go to the same route with the brain and say, all right, we've mapped it, now the simulations, the research that you can start doing on the neuropathy of anything from Alzheimer's to autism, it just takes a huge quantum leap forward. That's one that I'm personally really looking forward to. I think that'll be a milestone moment that's going to come out of national research at some level in a major supercomputing facility that really does need that level of scale to do it. And by the time you're 10 years out, you're going to have a new field of study. That's an example of it. It's my favorite.
And with that question, yeah, I think that.
Of the Blue Brain Project. He did. I take your point from an artificial intelligence standpoint. Let's separate AI from mapping the brain, because I think you can do a brain map for testing purposes that isn't in itself cognitive. But there will certainly be advancements in artificial intelligence along the way also. And that's coming up awfully fast. I mean, we have AI now when you call the 800 number for whatever, and a robot answers the phone and clicks at you as if you're talking to a person and encourages you to say the numbers out loud rather than pushing them on your phone. It's not very good AI. Yeah, Siri there. I mean, we have rudimentary AI now, and it gets better.
And I think I give this example to some of my students. If you really want to be imaginative and see what Exascale will come, take an example of airline industry. Okay, and obviously a lot of improvements have happened over the last 20 years. But imagine, let's say, some disruptive things will come, and from any place to any place in the world, you can travel in 4 hours or 3 hours. Imagine how the world will change. Those we have not thought, because we have not been exposed to that environment. But once such technology comes, like our interactions, how people travel, will totally change. Person like Gilad will start his breakfast in Israel, come to here for meeting, conduct 5 meetings in the world, and go back for dinner in Israel.
The previous advisory council meeting was in South Africa, by the way, and that was an excellent trip, but it did take a very long time to get there.
Yeah, including riding on elephants from the airport to the conference. So with that, I'd like to thank Rich, Addison, and DK.